Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
Good morning. This is Greg Hutchins.
Hey, Greg. Yeah, I hit record and then I had a thought about what I wanted to say. And then I said, oh, yeah, I better introduce ourselves before we get started. The last time we talked, we were talking about AI and language models and training sets. And we talked about fracas briefly, about that might be a source as for an internal system to help. AI could possibly help interpret things that are in individuals' language versus some common language that we all understand clearly. You know, all you have to do is try to explain the problem you're having with some product to the customer service agent. And if it doesn't line up exactly with their script, it's going to be a long discussion. But anyway, that's one thought of it. But what I wanted to ask you about is, and part of it is that there's actual data underlaying say a fracas system or a failure analysis system or a lifetime or field return data, stuff like that. And a part of the world in reliability that I have to deal with is that, we're getting stuff back from the field and we know it's coarse information unless you've got your system fully wired up so that it reports back its conditions on a regular basis. We have to deal with a customer saying, hey, it's not working, and then figure out, well, what do they mean by that? And all those issues that go with that. And we may or may not get good timing on it. We may or not get good descriptions of what's happening, all those kinds of things. So at some point, somebody's going to say, hey, Fred, how many warranty returns are we expecting next quarter? Given that we've shipped this product a year ago and we've been collecting information ever since. And my first response is always, I don't know, let's wait 6 months and we'll find out. Because we really don't know. And that's not acceptable. We need to make decisions about warranty accruals, staffing, spare parts. There's lots of reasons we need to forecast this kind of stuff. So we have this troubled, in most cases, data set that we're dealing with. And my first approach and my inkling typically is to say, all right, well, I know when it's shipped. I know what week we manufacture it. And sometimes I know when it got installed. Some systems allow us to do that. And we know when the customer complained about it or alerted us that it wasn't working, or some systems, the system itself tells us it's not working. And so I know when it got put into service and I know when it got reported not working. Oftentimes, I don't know how often it was used. I don't know if it was sitting in a warehouse for 9 months and then got installed and it was out of box failure, or I don't know exactly what the failure is. And so the data gets really messy real fast. But by and large, people buy a product and they start using it most of the time, for most products. And when it fails, if it's worth their effort, they'll report it failed and get a replacement or get it repaired. And so we hope the data is good. But then I get all this set up. And my first approach is typically saying, all right, well, I know this time to failure information. I'm going to do a Weibull plot. I'm going to do fit a distribution to it and use that regression analysis results, this equation, to extrapolate what's going to happen in that next quarter and can answer the question. It's pretty straightforward when you have good data, or reasonable data, I think is the right term. And I saw a paper just this morning by one of our fellow contributors to Shendo. Larry talked about using non-parametrics. He said, and what caught my attention, I wanted to talk to you about, was the data itself is what it is. It's a reflection of reality, right? The reality we may never know. Some people won't report they had a failure. Some have never used it, and forgot about it in the warehouse and never installed it. And I remember one person, they were dealing with pumps, and they said, well, the pumps failed on the ship. They always carried a handful of spares with them so they could continue their mission, continue what they were doing. And then they get back and they stick all the broken pumps on a pallet and ship it back to us. So it might be the end of a 6-month sailing, and now we have 8 pumps, and they might have failed at the start of that 6 months or the end of the 6 months. We really don't know. They just shipped 8 to us all at once. And okay, well, that's a different problem. So what Larry talks about is all you need to know is, how many you shipped and how many you got back. And just use the non-parametric. You know when they came back and just plot it. Just make a simple line graph of on Tuesday I got 2 back, and on Thursday I got 6 back, and on next week I got 1 back. And you're not trying to fit a line to it. You're not trying to draw a curve through it or anything like that. You just observe the actual data. Is kind of the gist of what he does. And then there are techniques then to model that data. It's not the same as regression analysis, but it's similar, and make forecasts or predictions from that. And the difference between the two approaches is that if I want to fit a Weibull plot to it, I'm making a whole raft of assumptions about the data and in order to use that kind of analysis versus just plotting the actual data that I have. I'm assuming that it's a smooth process, that it's going to fit a curve that's nice and clean. And usually we plot the data versus the curve to see if that assumption is true or not. And then we convince ourselves it's good enough, kind of thing, all too often. So the question to you, Greg, is, coming at it from a lens of, decision-making and risk and all that other good stuff is, well, how many assumptions is too many? And then to get even deeper into it, how many people making decisions actually understand the mathematical and analysis sets of assumptions that are being either consciously or unconsciously made?
Wow. Okay. So just for our audience, I think you hit it right on the nose. Most of the data that we use is parametric. Why? Because we can put assumptions on it. We can use various tools. We can curve fit. We can do a bunch of stuff. Mm-hmm. Non-parametric data is basically data from the field as is. Mm-hmm. But there are assumptions in it. And there are big assumptions. For example, what's the context of failure? What is the failure? How is failure defined? Why was it returned? How was it used? So the very fact that you're defining non-parametric data has assumptions built into it. There might be a subtext that, but they're actually, there are things behind that are important in the analysis.
Yeah. I think the simplest way to look at it is if the customer returns it to you and is asking for a warranty, it costs you money. And that's failure of your product and product design and understanding the customer's expectations. And for whatever reason, all too many organizations then say, all right, we're going to take this return product and we'll put it on the bench and we'll see if it works. And it fires right up. It works just exactly like it should. And they go, oh, no trouble found. It's a stupid customer.
That's a
they
great
blame
example.
The customer.
And by the way, in a lot of field failures, especially with very complex products, that's the problem.
Yeah.
You've got too many buttons. You have an uneducated, that's a poor way to say it, and a user or customer that hasn't been taught how to use all these buttons, right? There's an expectation delta or a knowledge delta or a user delta. What happens is the returned product, non-parametric, would say that's a field failure, when it really isn't. It's just simply lack of knowledge or lack of understanding by the customer or a poorly designed product.
Yeah, I'm running into that with my cars. We just went through the daylight savings time change here last weekend, as of when we're recording this. And we know that we need to go into the user manual to figure out how to change the clock in the car because it is not obvious. I think it involves taking one of the tires off, and there's a button underneath there, but I don't remember because it's such a painful process. But anyway.
So is that a failure?
Yeah, I have thought about returning the car and saying, hey, this is...
Oh, so now you're going to return the car. That's
because
going to be
I can't change the clock.
Non-parametric. That's going to be a non-parametric data point. And is that real?
Well, the car works perfectly fine if you could actually figure out how to do something with it.
But that goes back to the fundamental assumption, your ontology of what is a failure.
Yeah, for me, it's anything a customer calls, returns, or whatever. If it costs you money...
It's too broad. You have to define
in our
world. In our world, yeah. In the risk world, everything, and I'm especially now with AI, because that's where a software shop, everything has got to be framed, contextualized, framed, nuanced, and yeah.
Well, the nuance part's going to be pretty flaky because I actually, years and years ago, we needed a new car, and my ex-wife and I said, yep, we need a new car. And so she stayed home to watch the kids, and Saturday afternoon I went out to buy a new car. And we kind of knew what model we wanted, what brand, dealer and brand, type of car we wanted. And as I'm heading out the door, I says, do you have a color preference? No, pick whatever color you want. Well, that was a big mistake. 2 weeks later, I'm returning that car because it was the wrong color. Cost me $2,000, got the right color car, and I drove off the lot. And they got a lightly used vehicle back that they could, sell as, nearly new, but not get the full sticker on it anymore because it was the wrong color. And it's not their fault, but it cost them money, cost me money, right? It was a failure of the system. And the people are part of the system. Your customer is part of the system. So my argument on what a failure is anything that costs you money. And it could be they ordered incorrectly.
So the return would be non-parametric.
Yeah.
How does somebody use data on the fact that you were ill-informed or didn't know how to push the right button? Well, how are you going to do any analysis?
Well, it's same with your software system. If I don't know how to advance to the next step because you have to swiggle your finger in a weird pattern to make it do that, but that's not anywhere in the instructions or setting expectations or not in the UI at all. Is that the user's fault or the designer's fault? Remember, I was a manufacturing engineer early in my career. Therefore, it's always the designer's fault. Always. We would not have UI issues if the design of the UI was perfect.
So I'm going to give you another little problem. The technical reliability of a mechanical piece for field failure is something that we can analyze. We can do, we could put on a bench, we could do life testing. We can figure out what's wrong with it. Yeah,
if like a motor fails, we know there's like a dozen different things to check right off the bat. And if you see burned wires or you see a bearings, it's fallen apart or a shaft fractured, we can get a pretty good idea that there was something mechanically wrong with it. Yeah, we can do that.
And what happens in your world, it's causal. A causes B.
Yeah.
So what happens if we're in a world, and I'm moving to the AI world, where the decision-making is correlative? You've got inputs and have outputs, but the relationship isn't causal anymore. It's correlation.
Well, we run into that with field service places, field repair centers, right?
Why? Because there's the human element now.
There's the human element, but there's what muddles it up. And I've seen this in some organizations are much, much better at this than other ones, is there some technicians, and I used this example in the last time we chatted, was they just shotgunned it. It's an actual process. You shotgun it. You say, oh, it's not doing this. All right, I'm going to replace these 6 parts. And so they have this correlation going, if I see this kind of problem, it's probably in one of these 6 pieces here. So I'm going to replace those 6.
And the operative word is probably.
Right.
That's the correlation.
That's the correlation part. And so they, And they kind of refine that over time. And so they're still not really getting to the root cause or the understanding of it. Years and years ago, Hewlett Packard, before they did consumer products, they did failure analysis to the component, basically, and the network, and what caused that part to fail. Was it itself, or was it something else? Things like that for every failure. And they were making test and measurement equipment, and they were really, really good pieces of equipment, and they were expensive. And part of that expense was they would spend the time to really understand every failure. They weren't shipping millions a month. That was long before they were doing consumer products. And they gathered the detailed engineering information they needed to make substantive improvements to their products. But they invested heavily in doing that. Whereas all too often it's get the line running again, get the repair done so the customer has their product back. We have this huge pile of stuff that really works, but we don't know which of the 10 failed. So the customer's happy. They get their stuff back and they get it fixed quick. They get the line back running, doing whatever, but that's where the information basically stops. And the underlying, what failed? Well, it's hard to tell when vast majority of the things we fixed and used to fix it are still working. Or, that is the problem I have. We have the parametric information, and there's plenty of issues with that and assumptions underneath it. When you step, though, to a regression analysis, or you step to another level of analysis, there's still piles more assumptions being made. And so, defining it and getting it all chunked and parsed and stuff is great. And I don't see that very often in reality. There are occasions, there are teams and efforts that are made to do that. But vast majority is the best we get is what Larry's dealing with is, when you shipped it, and when it came back. Deal with it.
So let me add a little more complexity to the problem. Assumptions basically are guardrails, essentially, to solve a problem, especially with correlative or hallucinatory data or process. So we went from a causal process, where you could do an RCA or root cause analysis, to now a correlative decision making. Now, what do we do with hallucinatory generative decision making from an AI system? The inputs can be, and by the way, the inputs, the data sets can be horrible in terms of quality. Then the process of taking the input data is unknown, unknowable, or unexplainable. And then you're getting outputs that are hallucinatory.
Yeah. Yeah. No, I agree. And
so the way to solve that is through assumptions, guardrails. But still, the guardrails for this undeterministic decision-making, and that's the word. Deterministic is causal. This is undeterministic, meaning uncausal or hallucinatory. So what do you do if you've got that type of system using public data, ChatGPT 3.5, or whatever you're using? The solution to that is the thing on the previous thing that we talked about, RAG. You use your own decision, you use your own data, proprietary confidential data, to feed into the system. You actually define with guardrails and assumptions the decision-making process, and then the outputs hopefully will be a little bit more accurate because you've chunked the data and you're chunking your data in a decision tree. That's the solution.
Yeah. If we do that, then we wouldn't need AI very much. It's kind of my thought. The systems get complex pretty quick, so I don't disagree that AI would be very helpful. The discipline of sorting it out, it'd be, I heard it on the news last night is they were talking about AI and the trustworthiness basically of it. And I thought of you there. And, if you create a internal data set and you're populating it and you're chunking your data, you're doing all this good stuff. And I present it with, this pump failed and it was in these circumstances and this situation, here's the symptoms we're seeing. What caused the failure? If one of the answers is not, I really don't know. How about getting more information about this, and this? if that's not one of the options, then I'm not really ready to start using it yet.
That option should be built into it.
Yeah, because it's at some point, the probability of it being A, B, or C are all bad or all low. And so a human will say, we really don't know enough to pick one of these. A rational human, I would think. So I think the AI should say, the numbers aren't supporting any of these as being the front runner. So we need
option
more.
E.
Yeah, option E. We don't know.
That's right. And, option E would have another decision set to it, a decision matrix to it.
Yeah. Do we want more information? Or is this worth pursuing? Is it worth the investment? I mean, there's all kinds of stuff that would go into that.
Absolutely. Like ROI.
Yeah, exactly. Well, Greg, with these two discussions we've had, this one and our previous one on AI, you're bringing me around a little bit. It's kind of scary. I'll have to go find an AI system. So, ask them if I can trust them or not. And given my skepticism, should I trust you or not, and see what happens. Maybe the next time we talk, I'll let you know how that goes.
Hey, this is a brand new dark universe. That's all I can say. So a lot of people will make money. Hopefully, we will too. Meaning, I'm putting you in the same bucket as me.
Yeah, I just want it to be useful. That's the part that gets me. But anyway, if you're listening to this and you think, "What in the world are you guys talking about?" As Greg said a number of times, this stuff's coming, right? It's in all kinds of different industries, and we, in quality, reliability, and lots of other engineering fields, make decisions all the time. How are you using AI to help your decision-making process? I'd be very curious about that and see what other stuff's going on there. What's available, what's not, and where are the opportunities? Let us know. Head over to ascendoreliability.com/go/SOR. You can find a couple of ways to get in touch with us. Greg and I are available through LinkedIn as well as the other hosts and through our About pages on the site. Plenty of ways to get in touch. So we look forward to hearing from you. With that, Greg, so when's your app going to solve all of our failure analysis problems?
When I have access to your data.
All right.
We could build a RAG in 2 or 3 weeks and then start, making it better.
Well, I'll hold you to that. I'll talk to you in a month and see how it's going.
Okay, buddy. Right. Have a good one. Thanks.
Talk to you later.
Bye-bye.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.